Okay, we are recording, and Zach and Taekwon, this is for you. If you can catch this recording, then you'll get credit for being here. Okay, I'm doing this because you guys are out for self-reporting, and I hope things clear up real quick so you can get back. So this is Durward King of Samson Community College. This is ELC 117 motor control on March the 10th, 2021. And we're in chapter 6, and we're going to look at something here that deals with transformers on the secondary of your transformer, where our 120 volt is for our controls. We have some transformers are grounded on the secondary on the neutral, and some are not. If it's grounded, it's called a grounded secondary. If it's not grounded, it's called floating. So I'm going to just show you here with the webcam a picture in the book here of a transformer here that's not grounded on the secondary. This one here is not. This one is grounded on the secondary on the neutral, like you've been doing on your labs. That's considered a grounded secondary. One that doesn't have a ground on the secondary here, you don't see the ground symbol there. It's called floating. There's a difference on how you have to use the meter if it's grounded or floating to get a correct reading. So I'm moving the camera again. Now here's our subject, guys. You look right up here. This is going to be very, very brief, but very important. Very important. Everybody watch it. On the set, when we step our voltage down from 208 or whatever it is down to 120, we have our hot wire, and it goes to whatever controls that we have. And then on our neutral side, coming from the starter and the overload, we go back to the transformer. Then we also ground that this is the neutral leg, and we also ground it, right? Try to include, when you got two guys quarantined, I'm trying to make sure they got some way of joining in with what we're doing. Okay, so help me remember to move this thing, whatever I'm doing, if you will. So those of you, Taekwon and Zach, if you're out there watching this thing, normally we do ground the secondary neutral wire coming back. If you do that, that's what's most common in the industry, and it's considered to be a grounded secondary. Now, when you do that, here's the way you properly test for voltage. Let's see the meter here. The book tells you this. It tells you that if you ground that secondary there, when you go to troubleshoot the circuit, watch this right here. You can go to any grounded point in that circuit, any grounding that you want to on that control panel. Any ground, that ground or any other ground, and then test. If I go to that ground, I can check and trace my signal out, and I will get an accurate reading on the meter. Now, let's say, for instance, if I had a different grounding point out here. I've got a different ground point out here, a different ground, but it is a ground point. If I've got the neutral grounded, that means I can actually put this lead out here on any ground, any actual ground, and still get good readings on my meter. Everybody understand that? As long as the neutral is grounded, then you can use for your reference on the meter any grounded point in the control panel anywhere. Okay. Now, what happens is if you go up here to this circuit and you disconnect the ground from the secondary, that neutral wire that comes in from the starter over there, from the coil, from the overlay, if you don't ground it, if you do not ground it, then it's called floating. If you don't ground it, then the secondary, that 120 volt, is considered to be floating, not grounded. So when it's floating, here's what you have to do to get an accurate reading on with your meter. Only one way. You have to go to the neutral wire with one lead of your meter and then test your signal, with your other. You can't go to just any ground. If you go to some other grounding point other than neutral, you're going to get some bad readings, and we're just going to demonstrate that. And that's the whole point. Is that for your reference on the meter, for your reference, if you do not ground the secondary, if it's called floating, and every now and then you hit a system that's that way. It's not very common. It's uncommon from my background. If this is not grounded, if you don't bond that neutral to ground, if you do not, then neutral is the only valid point that you can use as a reference point. You've got to go to neutral like this. You got to go to neutral. You got to go to neutral here, and then test your signals going through the system, and then the meter will read correctly. Now, with neutral and ground not hooked together, like here, they're not hooked together. When they're not hooked together, watch this. If I go to ground and I go to here, you're going to get a bad reading. It's not going to say 120. It's going to be some way off number. Okay, so when I go from ground to here, it will be a bad number, but if I go from neutral to there, it'll be a true number. So therefore, I got to put one lead of the meter on real neutral to check my signals as they go through the circuit. Now let's just demonstrate that, and it won't take you but just a second to see it, and you'll know that this is the issue between floating and grounded. Okay, so we're going to cut it on. And the reading that you get will actually be very unpredictable. It'll be very unpredictable. I've seen reads as high as 140 volts that way. And then on this one, it actually reads like about 30 volts to ground. If you don't ground neutral, it'll read about 30 volts. It's something that you don't know what the number is going to be. But it's definitely something that we need to look at together as a group, and tell me if something's not making sense about what you're seeing, because you will definitely run into this out there in the industry. You will run into this issue. Okay, everybody got glasses on? Everybody got glasses? Going hot? Roger, you got some glasses? Yeah, got some glasses. Yeah. And pay attention. I'm only going to take a minute of your time here. Watch what we're doing. Don't miss it. You're only going to have a minute to see this, and then we're going to start checking your lab. We're looking at from Barney's looking at from here on out, maybe spreading these things out in 4 days, having short classes for 4 days, looking at maybe going back 2 days and making them longer. Yeah. Now, going high here. Going on. Now watch this. Now, just so you'll know what the circuit is, you cut that off there. We're going to start out with it grounded, okay? We're going to ground the neutral. Now, for those of you that don't know what the circuit does, this is a lab that you'll get to if you haven't done it yet. Everybody watching? Everybody watching? Watch the circuit here. Here's what the circuit does. You're taking the 120 volt and you're going to a selector switch. The selector switch is a 3-position. When you put it in to the left on hand, over here on the left for hand, here's what you get. The power goes straight to the motor starter, and the motor comes on, and the pump's just going to run constantly with nothing controlling it other than the switch. That's going to be in hand. That's going to be for a pump motor to pull water out of a pit for waste treatment. Now, if you put it in the off position, it's never going to run. Both of them are going to be open, and the pump motor's never going to run. If you put it in automatic, then the A contact, cut it off. Yeah, cut that off. Now, it's a little water now. I got it on now. Now look, y'all pay attention, please look. What this circuit does is this. Is everybody watching? You see the float right here? You might want to stand back so the guys can see. There you go. You can run this thing in hand. If you run it in hand, the B contact makes and it pulls the starter in. The where it's just going to run all the time, and it will run. It'll actually bypass the float control. That's you put it in hand if the float actually goes bad. So if the float never does cut the pump on, you can put it in hand to see will the starter run. It's going to tell you if the starter's okay and if the motor, if the pump's okay. That's in case if the float never does trigger and you got really high water, okay? In all position, both of these are open and the float will never run it. You're basically you're disabling the whole circuit there by putting it into off position. Now you go to auto, and then it opens this up and it closes this one, and then the float does it automatically. So as the water rises in the pit, it's going to cut the pump on, and then there'll be a ball tied to this, a ball float like in your toilet. And if the ball goes down and the water goes down, it's going to cut the pump off. So it'll run automatically that way. So this is for water control, for wastewater control in a pit, like under a hog, for a lagoon, under the in the hog farm under the floor where the hogs their waste is going. Is that in the lagoon? In the lagoon. So anyway, if you trace, we're going to cut the float off, and we're going to use this circuit as an example of what happens if you have it grounded. Now take your meter and let me hold the meter, and then you hold the probe. So that way you can actually see what's going on here with the meter, guys. Now look. Yeah. So we're sitting here. Everybody look. Everybody kind of get around where you can see the meter. Come on around this way where you can see the meter. Now look, he's got one probe on ground, and he's going to check. He's checking his voltage there, and look. Now check it. Say going into the float, for instance. He's checking it going into the float. He's getting 120 volt. Now watch this. He got 120 volt leaving the float. And that's correct. Now he's got his common on the meter sitting over here on neutral and ground that they're together, right? Now watch. Move this to any grounded point. Move to some other grounded point. That ground over there. He's putting his reference point on a different grounding point, and he's also checking the float coming in and out. Look, 120 volt. Y'all see that? So he was able to go to some other grounded point with his reference probe and still get a good reading as long as neutral is grounded. Now watch what happens here. Cut your float off. Now we're gonna get rid of it. But you gotta have that. You got to have that. No, you got to have neutral going back there. What we're doing is we're removing the ground jumper from neutral. Oh, okay. We're not going to ground neutral. Look, everybody watch. This only takes a second here. Look, step back over there and let everybody see this. What we've done, guys, we've taken that ground jumper that was on neutral and we've removed it. So neutral is still there, but it's not grounded. That's called floating. You have a floating neutral there, a floating secondary that's not grounded. It's not grounded. It's still 120 volts, but neutral and ground are not together. They're not bonded. Now let's cut it on and see what happens. Cut your float on. It's still running, isn't it? Now look, you still got 120 volt. Go from neutral to your float. You got 120 volt. See that right there? Everybody see it? 120 volt going to the float. That's when you're using. You moved it. You moved it. Now look, listen. When he checks from neutral to the float, you get 120 volt. 120 volts. See it? Now move over to ground. You're getting 30 volts. You see that? Yeah. Nathan, you see it? Yeah, 30. 30. Listen, you're reading 30 volts from ground to the float when you don't ground the neutral. Does everybody see what's going on? You're getting a false reading. you get the false reading when you don't ground the neutral. If you use ground as a reference point for the meter. So what do you do if you got a floating secondary like this, ungrounded? How do you properly measure it? You go to the neutral. You have to go to neutral, and then you're going to read the 120 properly. You see it? And then one more time, go from the float to some other grounded point. Yeah, 30 volts. You get a bad, erroneous reading. Yeah, come on up, Alex, get you some glasses. What we're looking at here in the book is it talks about floating and grounded secondaries or controls. And the idea is, you've been grounding your neutral wire, right, on all of your circuits. If you do ground them, you can take your meter and go from any grounded point in that circuit with one probe, and then take your other probe and do your test points. Now demonstrate it again. Let's go here. Watch close. We've got neutral grounded right now. So look, he's going from a different ground point to the float. He's getting 120. You see it? Now, so you can use any grounded point for a reference if you got your neutral grounded. No matter where you go, it's 120 in that circuit to any ground, from any ground to the float, right? Now watch this. We cut it off and we remove the bonding jumper. We cut it back on. Now he's going to measure from ground to the float. He's getting 30 volts. You see it? When you go from ground, see, ground and neutral ain't together now, so they're not bonded together. You're going to get a false reading if you use ground as a neutral. So he's going down neutral to your float, and he's getting 120. You got to use neutral as a reference point with a meter. Go from neutral to your signal to get the true reading. You get it? But if you go ground to the float, you're going to get a bad reading. So you can't use ground with a meter if you have a floating secondary. That's the bottom line. You can't use ground with a meter. It's convenient to get to. Most people do just find some grounded point to use, and then they test their signal with the rev probe. You can only do that. You can only do it if you ground the neutral. So here's what can actually happen in reality. Hold your meter. Sometimes, look, everybody watch. Everybody watching? Sometimes the connection here that you have between the transformer neutral and ground can be rusty. It can get loose. If you get a bad connection from ground, between the neutral and the ground, like a rusty situation from moisture that gets in there, and you get some resistance in there, then it's actually produced a problem for you that you cannot use ground as a reference point anymore. So if you ever get in a panel, even though the neutral is grounded, and you see a grounding jumper there, if you see rust in that panel, if you see rust in it, like on a hog farm or in a food processing plant, and there could be rust in there where the ground connection is, if you're using ground but you're getting some funky readings, then get off of the ground and you want to go to the real neutral. Go to the real neutral for your reference point and use neutral as your reference, as your 0 volt reference.
You're saying if the ground is hooked up to the neutral?
Yeah, if ground is hooked up to the neutral, but you have a rusty connection, a bad connection that's become rusted or corroded.
Disconnect the ground from the neutral?
Yeah. I'm telling you that if it is hooked to ground, but it's a rusty connection, if it's a bad corroded, you'd have to take it off and scrub it with sandpaper or something like that to clean it, and then reconnect it to be able to use ground as a reference point. You know what I mean?
Just still use the neutral.
But bottom line, you always go best if you use neutral for your reference point for the meter.
Right.
I'll throw it on neutral as a habit, and you will not go wrong. If you're using ground, it may be good or it may not, because of rusty connections, loose corrosion, stuff like that, and it can make you think you got an issue that you don't really have. Or it could point to a bad ground connection. So that's basically all we're saying. Everybody understand?
Yeah.
Okay. Thank you. Well, we'll let you go ahead and measure, do a couple of measurements there. So when you cut it on, yeah, like that. Hey, let me give y'all a bug at the same time. Come on over. Let's do a troubleshooting bug at the same time. Since we're running short, these are some short classes. I'm going to put a bug in real fast, and y'all help me figure out what's wrong. Get some glasses on. Yeah. Now come on over. We got one bug we're going to troubleshoot. So here, if you look, guys, the float is what actually gives you the control voltage. Put your meter across the coil there and tell me what you get voltage wise. Roger, let you hold the meter up there for him. He's going to check coil voltage with the float on, with the water up in the pit across the coil, here and here. So what are you getting? He's got 120 volt across the coil. Now listen, leave your leads on there and watch. When the float's up, you got 120. I'll run this. Look, if you go down, when the water goes down, you lose the 120, right? Now the water comes up again. It comes on, the pump runs and the water's high. When the water goes low, it cuts off. Now watch this. Watch this. Now listen good, listen. I'm gonna cut the float on. Look, he's got 58 volts across the coil now. Hold up good, Roger, everybody can see. Yeah, 58 volts across the coil. Now look at here. He got 58 volts from here to neutral, right? A while ago you had 120. Now watch, take your meter and do this. Leave one probe on neutral and then come over here where you leave the float, check it here, and then check it going into the float and see what the difference is. So leaving the float, 58, leaving it. Cut it back off. Yeah. How much is it going in? 118 volt coming in and 56 volts leaving it. So what's wrong? You got a bad float. The float contacts have gotten corroded and it's gone bad. So what I did, I flipped the switch and made the contacts be bad. That's called low voltage. If you have a low voltage condition, when you have low voltage getting to the coil, low voltage is going to make it pull in, and it can't. It's going to chatter. It will chatter under low voltage like your vehicle does when your battery's weak. How many of you have been in your truck or car and you hit that ignition switch and it wants you to go tick like that? So it's under low voltage. You notice your starter wants 12 volts, but maybe it's only getting 8. So you're starving the coil here when you do it into low voltage and it just chatters. So I'm going to remove the problem. Now cut it back on. Now, read your voltage again. And hold the meter up where everybody can see. You're getting 120 now across it because I put a brand new contact in there, okay? Fixed it. I've got fault switches I can put in, and it actually puts resistance in there behind the board. Anyway, that was it. That's a bug for low voltage on your control device. Just bad contacts, okay? And anyway, so that you can do your measurements here. Look, check your voltage, leg to leg and leg to ground, and then check the amps, and that'll be it. Then you untake it apart. Somebody else can wire it up. Somebody else can have this board now. Whoever needs something to do. So, tell me the numbers. Okay. Okay. And it each laid to ground. Okay. Good. And now check your amps. Good. Okay, that's fine. You would normally have a nameplate, and you would refer to that. That nameplate's missing, but you've been seeing them all. You would go by that as far as your amps, what it should be doing. Now, This is freed up for someone that needs something to do. If you're way down on the list as far as being checked, we're checking you now. So get your PPE and we're heading your way. Yep. Right, Luke, if you unhook yours, but if somebody's back on the list of ways, go ahead and grab this and do it. We're gonna be checking your plywood boards over there now. There's your meter. Yes, sir. Yeah, I don't mean to be rushy, guys, but these classes are just too short. There they are. We talked this morning. I had a meet with Barney about some different things. He's looking at doing this stuff going back to 2 days and making them longer. And because by the time we get started, he said the welding classes had the same problem. When they cut it about an hour and a half, by the time they get their stuff set up to weld, it's time to go. You know, it's not working out for them either. You know.
You know online?
Yeah, I'm recording. Sure am. Yeah.
You got somebody online?
Well, there's nobody on there right now that I know of, but I'm recording for Taekwon and for Zach. There's nobody's in, but I'm recording so they can go back and watch it. You know, they can go back and watch it when I upload to YouTube. They can go back and watch it. See, them guys, they'll be out for 2 weeks. Taekwon self-reported now. I don't know if Zach has or not, but his roommate's got COVID. Zach's roommate does. Yeah. Yes, sir. Chapter 6. Okay. Yeah. I've got your drone right over here. Let's get your drone right there. You get hooked in your overload. You went right from here, straight back, and you actually went basically you went from here back to there. You didn't do that at all. Just went straight back to the you went from 14 straight on back to there, and you didn't include this. Right, put the bed in. That can include that counts two bits of wire. Other than that, perfect. Yes, sir. Good deal.
Hey, Harold,
Yes, sir.
I haven't checked my email lately, but are they up on that spring? I mean, summer yet?
No, they don't. Registration's not gonna open up till I gotta check on my thing here. I think it's
David said he thinks it's 27.
I saw it on the board in your statute.
Somebody can use it on.
I gotta look at the next.
It's going to be. You can get Colonel Good. He put it in.
This is yours. Right. Back here. Hey, Brandon.
Just like saying.
Brandon in there. Yeah, I was gonna give him a VFD pound. Let him have something to be doing since he's playing.
I'll learn it.
I don't know if they have that. I've got a card here, I put all of them on, you can take a picture of this. Just get a picture of that. That's my name, Jay. Put the man, that kind of,
I thought you were taking over all the electrical.
well, I was,
Change it?
I was asked what I do. And the way it was presented was, would you do it if you were off? And I said, yeah. And I thought that meant it was going to be. Well, now I found out this morning that they know that I'm willing. But here's the problem, They were limited on maybe eliminating this program and going to just keep it 11, which I thought was a bad idea. I think these programs, Sampson County. If you swing whatever's right, and you say, let's just be electrical experts. Well, that's good, but it ain't really 100% good, because then you don't know, you think diagnosis if you're electrical, or is it that song? Right? And that's where I was in '86, and I didn't know what song about was. I found all that time. And I had to learn, mechanical stuff. To know, to be a good technician in general. Right. Be strong on the electrical, and also on the fluid power. Because yes, what do you see that you get a great deal because how do you move this? Is it the source of the signal, or is it the valve, or is it silver? So that's what I ain't learning to do. We're teaching them here, but we're going to get a little bit. So you make a long story short. They're advertising for someone to come in this program and teach them mechanical stuff, and whatever kind of talent they get. They don't know who they're going to get and what they're expecting.
That's, it's good for somebody that's had 1 year experience out in the field.
Right.
Not actually.
We don't know whoever they hire, we don't know what their strength is going to be. Therefore, we don't know what classes they're going to be able to cover, which ones I might have to cover, character, for instance, maybe. We don't know. That's what's up in there. He said that he can't guarantee right now that it will be that way. Because we don't know who we're going to get. That's what it boils down. All it boils down to is being personal. That's fine, plug me in wherever you got, you know, I can move. And I know
What they're talking about doing away with it, industrial maintenance.
well, what it is, the numbers are kind of going down some, but now they're looking at not letting go of it because the needs of the county.
I'm not saying that, when they, well, I just go within the my degree, I already signed up for
Like, they don't do that.
But then they're going to cancel out the last.
They're not gonna do that.
I hope not.
That'll be the classes out there for some.
This, I've got everybody, right?
Yep. I don't know how to do it.
You just share, if you did click on the share icon. But, I had been going there telling everybody that I was going to be recording.
Well, yeah.
You see, word got out, and I was saying that, but it's not a, it's not like, it didn't actually get said in the sentence.
I'm more familiar with you.
Well, see, here's what I was told about him. I don't know if he's registered, but we ELC.
Well, see, I remember you telling me
He's
that.
got first and second year students, and that's basically, he's got moving and second year people. And I was told we're going to have time to do well. So they asked me what I do. And I said, yeah, if it's a kid, so he didn't take it up kind of rough. And the doctor told me, I said, we can't let go of protocol, we can't let go of this and that stuff right now. We got to make sure that everybody's covered, if we don't leave nobody hanging. But what I had done is I had told the time they had been, hey, I've been off the full time over here. And we can start looking for somebody for protocol, we can find to do what I do for them. And then now we're finding out that ain't gonna fly. Protocol says they don't do. They
Well,
won't.
you know your stuff.
I think we just need another dozen.
Right.
Yeah, that's what we need, is another
That's what my
donor.
mama said. She didn't.
Well, that's because you know your stuff, and everybody that's already into the program,
Yeah.
they recommend you real quick, because they know you know your stuff. Not saying they don't, not saying anybody else don't, like you guys just, he's more, as I'm saying, he more gets into the nitty gritty, what we really need.
Well, see,
I mean, the book says they're gonna take everything. The hands-on is more.
So what we're going to do is special see who can help us play out.
Okay.
That's all, and I just told them today, I said, look, it's fine to make whatever you want to do, just, I don't even have to know the way out. Every time it makes a mess, they didn't know that, and like, beyond that, it's okay, whatever, I'm flexible. And that's stay that way, basically, I think that is behind the plant. Cause we might have a hot machine operator to be out on vacation week, I might end up running the machine plus, maintenance float drain. You just do whatever, you know.
What's the CIS? It's probably comfortable.
It's like an easy peasy, elective,
It's a computer class.
intro to computer, yeah.
Oh, it's like word of mouth. It's pretty good.
Something like that, yeah. It's one of those electives, you know, you've got to have so many electives, and that's one that, it's, you know, you
And I have to, don't I have to do the HVAC and all that in my degree?
do,
That's what I thought.
Well, you got enough for me.
I'm doing it enough for me.
I gotta do it too. I mean,
They ain't doing well next semester?
yes, sir.
Then you summer, that is something, this summer we're going to summer school. So they don't hold summer voting?
well, I don't have a real question, because we're doing advisor, and through the search percentage,
So I already did the intro welding, so I gotta have the hands-on now. I want to do the nights with, I can't remember his name, like, who? Yeah. That was in our residential class. He, man, he know what he's talking about. Yeah, that's it. He works at, Schindler Thomas. That's why he's in the night class. But he knows what he's talking about. He can tell me about how much she's not going to get. You better learn something when I get off. I didn't like the intro. You know why I didn't like the intro? Because that was a semester. We didn't come to class. We had to be everything on our own online. Even though I passed it, I can't get to comprehend that good. Right. I couldn't comprehend that good. That's why I need somebody really know what you're doing. Even though I know it, but still, you know what I'm saying? I don't know a lot of the terms. But she, it would help with the way. You know what, Rob? That might not look all pretty and everything. That's what you got to grind for. I'll make it look pretty. Yeah. I can't think. And I think a lot of it has to do with nerd. So I got to sit here and be a very nice person. I got to sit here and we look at it. I got to go shit to eat. I got to sit there and see, it'll go with the same. But never in private. If I ever keep a profession like that, I'll get that. I'll have air myself. I probably would be able to get that problem with somebody like Ian Jameson, because he probably helped me learn how to control it.
he's certified.
I know he is.
He's trained and certified.
Well, he's Canadian certified. I did not know that.
He's certified, he can actually, you're saying that you're certified.
Shoot, I did not know that.
Not bad. He's certified, you're
Well,
certified.
he knows how to do, stick welding, plastic, right? He can do anything.
He fixed it,
Last one.
I don't think that. One of them. If somebody does that, she does not know. We'll feel like it's going to that's why. we'll see what we're missing. So that there may be, a wire loose on there, let's get a meter and see what we got. Let's don't forget our Zoom people.
So all of them you did, they take free classes this summer. I know I have to take the computer class and I'll have both of them. I'm trying to get a full, at least 12 hours.
Yep.
So I get my full.
That's good. You need to get at least 12, fair enough.
I think, I don't know what the course amount.
You don't know what?
The course hours you did, was that over sheet?
It was hours long ago. The ones wrote down.
I must have got it off. You can see that part. Where's it at? Oh, course hours. I did take research. You good.
Now, so let's see what we're doing here. If I can include the camera here. So right now, whoever may be watching, we got an issue going on to where when he hits the start button, it's not doing anything. It's not switching over to the lights. So we know that we have an issue going on somewhere in here to where power's not getting to the starter. We know that much. So what you can do is we can, but we know that we got 120 volt because that red light's on. You can verify your voltage by checking from your neutral to your 120 right there on excess. So put your meter on there, Benjamin. And if you'll show everybody. He's got 109, close to 110 volt, that's fine. So we know we got control power. And by that red light being on right there, that means you got power all the way to there. So we got a home in right in here between the start and the coil. And you actually could go across the coil, A1 and A2 there, and measure that and see when I hold the button in, do you get voltage there. So if you go to the coil, your A1 and A2. So now, yep, when I'm gonna press the start button and let's see what do you get. You getting any voltage? Okay. Get none. Okay, now let's do this. Let's measure from A1 over to the real neutral at 96. So go A1 and 96, and we're gonna see if that overload may be opened up. So you're checking A1, and then you're going to check the 96 there. And so we're checking it there, and I'm going to hit the start button. And what do you see? Nothing. So what that means is you're completely missing. You're missing the signal here from the start button. That start button is never really getting to the core, which I'm going to guess is probably a wire that popped off inside that panel. Wouldn't you think so? That's what I'm guessing, because we know we got that 120, right? We know we got that red light, so that's telling you that you got it there, right? But you're missing in this section. So I'd say let's lock it out, open up the panel, and let's see what we got. And I think you're getting ready to find it right quick here. So we'll lock this thing out. Everybody can see you. This is tough. It's tough for whoever's out there, can't be here. We're going to try to include you with this until you get back. Hope for the best. They said that Zach, his roommate's got COVID. He ain't got it, but his roommate does. He's out 2 weeks.
Have you been tested?
I don't know.
He was in class the other day. He was in class the other day.
What day was that?
Maybe sometime this week. Beginning of the week.
Today ain't but Wednesday.
I think, well, yesterday's when somebody told me that, yeah, somebody told me that now, Taekwon reported himself. I got an email from the COVID team. He reported himself. I don't have an email about Zach. I just heard from Luke. Luke said that his roommate's got it. Not even wired. It's this one. This is the start button over here, not over there. We hit the wrong one.
Oh. I think I just had this for my life.
Yeah, you did. And I was thinking this was wired, but you didn't even wire these.
Yeah. Like you said,
It was over here, and I didn't see. I saw all the wires, and I thought that was the ones you were using. So we were hitting the wrong set of buttons. It's actually over here. I didn't see that. I saw everything together, and I didn't realize that it was over here.
I forgot about it too.
Mm-hmm. Yep. So that's.
Benjamin.
Too many lights, yeah. It's okay. I didn't notice it myself. No problem. No problem. No book follow. Yep. I'm going back out again. So you should be able to hit. You go to run now. Hit start over here. Let go. So you're actually in jog right now. Flip it over the other way, and I bet you switch it backwards. Now hit start again. Yeah. The contact we got the wires on the wrong contact in there. So your run is over here and your jog is to the left. So it's going to stay running right now until you either hit the stop button or if you get an overload. If you check if you want to trip the overload by opening up like that. You go in there and you slide that window to the left like this. Like that, and it says T in there, and it's trip. Now it won't start now. Go right here. It won't start because you have interrupted that neutral right there. You got a hot wire there, but you don't have a neutral here. You got it here, but you've lost it here. That'll pop open right there when your overloads get hot. It's in overload relay. Like if the motor stalls and binds up or something jams on the chain, the overload heaters get hot, and where it says OL, it'll make that trip, and just what happens once you slip. It just loses the neutral leg, the coil just disengage. You can reset it by hitting the blue button. Close this up. Just hit the blue button with it open.
12 o'clock this morning.
It's quick, and it cleared the fault, now it'll go ahead and run now. Yep. Right. So when the motor jams up for whatever reason, and it overloads the relay, overloads these heaters, those are going to cause that to pop open, and it's going to disengage. And when that opens up, it'll open these up and the holding contact will open up. So that's good there. If you put it in jog, go back to jog. Now it's only going to run when you bump it with jog button now. So just bump it. It'll make it bump like a conveyor. It can make the conveyor move a little bit if you're going to move the product a little bit and then stop. That's a jog feature there. What you've done with that switch is you're actually opening up the holding contact. You cut power from 13 so it can't hold down. So you're going to be some straight circle here for momentarily. It'll look like you'll never see it. That's what you would do. Now, as far as when this thing is tripped,
or you could do
when it's tripped like that. Well, by the way, the setting in there, that setting in there, the amp setting, that amp setting in there tells you where it's going to trip at.
That's when you set the job.
you set that at 25% above.
Now,
the
if you want it to be, right.
So whatever the motor
Now, if you
runs,
want it to just constantly run,
I seen that one, just.
yeah.
8.3. Yeah, when you're running at 208
I
volt,
see
it'll be
people do this.
8.3. If you're at 230 volt, 8.2, 460 volt, 6.1 amp. So you get an amp rating for whatever voltage you run. So you would take the 8.3,
But
that's
that's
kind of bad. You would boost it by 25%, you say 8.3 times 1.15. And then that's what you would set the other one for. And when it trips right now, you see it doesn't run. It won't run. If you put your meter across A1 and A2, get your meter.
That's supposed to be a good job out there.
you, when they first come, when they been there, it's really something.
When they open up, I think
Hold on a minute, my battery's running low on my computer. Let me get the computer plugged.
right there before you get to the Eastover, Durwood.
Mhm.
Where's that Campbell soup that just opened up a couple of years ago? I've been
There's a
5, 6
Campbell soup down close to Maxton.
That might be one.
That-
But ain't
that
that the
Max-
one that just
Well,
recently opened?
where your mama's boyfriend works at.
He works at the one in Maxwell.
At Maxton.
But didn't they open one up right there towards Eastover?
They
I
might have
remember
that
they were
much.
talking about, I don't know if they ever did, they were taking people's applications, and I put an application in when it first, I never heard nothing from them, so I don't know. They might have canceled it.
Yeah.
Come on back around now, Ben.
I heard they make good money in Kansas City. I don't know.
So when you measure across the coil right now, what it actually tripped. Go ahead and put your meter across it. And you're getting nothing there, right? When I press the button, look, you see nothing, right? When I press the button. Now watch on the schematic. I want you to move with your meter instead of checking from A1 to A2, check from A1 to 96 beyond the overload, and you'll be able to get a reading there. Because you've actually got a neutral uninterrupted out here. If you get on real neutral A1, beyond that break point, you'll be able to read that signal. So you got A1 and 96. Now, when I hold the button in, I'm sorry. Yeah, you're right. When I press the button in, you get the signal. See there? So you're getting the signal there even whenever it trips. It's telling you that you're getting the power to the A1, but you've actually lost neutral, what you just proved there. Now, now you reset the blue button. And you see it clear the window out, and then you can close this up. And now it'll start. You go back to auto, or you run, and hit start. Now you can check your voltage across A1 and A2, and you'll have it now. And so you got your close to 110 right there. Okay, that's good, very good. Now let's let you measure leaving the motor. Check each leg phase to phase go 1 to 2, 1 to 3, and then 2 to 3. Where it leaves the motor at.
I can't.
210, that's checking 1 to 2, now go 1 to 3. Good, and then 2 to 3. Good. Now check each one of those to ground. You can take your left hand and use this ground up here, your left hand. That way, or that way you don't have to cross over. Yeah. Now that's checking 1 to ground, now 2 to ground.
6, 7 moves.
Good, and now 3 to ground. Perfect. That's it. So that's exactly right when you have a system that's anywhere between 208 and 240. That's what you'll get. Now let's check the amps. So flip it over to A for amps, and you'll put you'll use the fork now to check your amps. So you're getting, I can't really read it. What do you get? 3.8 amps. Good. That's for first leg, second leg. About 3.8 again. Okay. 3.6, or you got to get all the way up in there. You can actually do it from out here, away from it. Look, just get in there, be fine. But get it all the way up in there. You know, position it. There you go. 3.9, that's good. Yeah. And the idea about an open fork clamp is you got to get in there where the lines are on the plastic. Those lines, the dash lines, you got to get the wire in that sensing area for it to give you accurate number. If that wire's up at the tip, it's not as accurate as it is down here when it's an open fork that way. Now, closed jaw clamping around there, it doesn't matter where it's at in the clamp. You get one of them clamp meters that actually goes around the wire, clamps. Then the other one with the clamp on it, yeah. They're more forgiving. So you're set. Now, the amps that you read there, you would compare that to the amps on the nameplate. And if what you read was above what the nameplate says, then you got some issues going on. Okay? You might have, the motor could be overloaded by what you're driving the motor, or the motor itself could be something going wrong with the bearings, okay? But you always want to compare the reading here to the nameplate. And you're within for sure. So that's good. Any questions? So I can bug this, man. I can put bugs in for you, and then you can troubleshoot tomorrow. Okay, sound good? Now, let's
But see, you know, RJ runs is so far. Now, I'm going to tell Derwin this. This was in the early 90s. They were already so far ahead of a lot of manufacturers that they already had the robotics that was running.
the next thing would be fuel start, and it comes to a 6 stops, where you can start, stop, and all you do. Since we're at the end of the period now, you're best off to let me bug it between now and tomorrow, and you do troubleshooting on this same circuit before you go to the next line. We want you to actually debug the basic circuit like this. We want to move on to something about more in it. Okay? Yes, sir. Now, what we can do here, guys, we can, I think it's the parameters you need for this. You got the plan start now? Can we show you the parameters you need for this program? I got the.
I was telling him, Derwood, when I used to work at RJ Reynolds years and years ago, it was like early 90s.
Is it right here? Maybe we might be starting that up again. All right.
They were so far ahead in technology,
Yeah.
but they already had.
Yes, sir.
The robotic forklifts. This was in the early 90s. They had the robotic forklifts with the track on the ground.
Yeah. Well, they were moving the top.
Yeah. You didn't have to move prop. They did. And the machines, you just gotta sit there and make sure they don't malfunction. That was your job. Sit there and care all day. Make sure the machine didn't malfunction. She's supposed to be off today, and they asked if she wanna work.
We're gonna check the wire and make sure the wire is good. But the parameters you're gonna need is verify. Okay, we'll see you. Okay, see you tomorrow. Have a good day. Tell Bill and all of the friends.
I don't need a man.
You did good on this. I'll put you a bug in, and then tomorrow you troubleshoot it, okay? I'll put you about 3 bugs in there. I'll show you how to get started and how to trace it.
And you got to put a bug in my side. Over there.
Yeah, we'll put a fault. I got to put a fault in that one. And then right down here, I've already got noted down here that you need one fault in yours.
I had put one in there for him, I'm not sure if he cleared it.
I ain't touched it. I ain't turned it.
You put it back in.
We-
Yeah, remember you told me before I left.
Okay, good.
Put it in there for him.
So it's already got the fault in.
Yeah.
Okay.
And I'll double check, make sure of that.
Yeah.
All right, there, we'll see you tomorrow.
Okay, buddy, have a good day. So Ben, I got it wrote down here to give you 3 bugs on that board. Okay. Now, let's see here. So on this one, your wiring. Circuit 11. 11 will be started on the gray area. Yeah. So 11 will be 24 volts. You took it on.
You jumped it around, you sent it to stop, you sent it to start, you also sent it to the full reverse switch. That's good. Then you took your, you left it, and it's hard to do the session. I don't know if anybody is going to be watching this or not, and probably not. I'll say this to whoever, whenever they're in person. So you wait for stop, and then you put a one stop. That's exactly right. You start. So you put switch. I think it's off. It's a good little bit. It's a lot of extra. Right now, it's just fine. That's 2. The full reverse switch is 3. Exactly right. And then your tensionometer is 12, 13, and 14. So there's 12 is the second one. Yeah, but that makes me nervous with all that showing, because if they get each other, it's consistent, so it's something out. You can need to shut them up, because they can actually get each other. So you're gonna have to look at it further. But it is wired now. So you got that ground, you got it. Now, on the other one, on the PowerFlex 4, they've actually got a terminal 4 ground. And it still boggles my mind that they don't have a shielded cable there. If you're close range like this, you're okay. But on longer range, you've got to have shielded. So I say shielded. Most times, if they're not saying they're going to go against some wiring trouble, they're going to be right side some of these wire cables. If you put them beside some of this and you don't shield it, then that interference can get in there and confuse the drive. It can make it think you're sitting there rocking with speed like this. It can be erratic on the speed. All right, so all that's good.
So that's correct wired in here as well?
It is. Now the orientation of it, I know it is correct. It would be. Well, no, your red has to be on the outside. Okay. The clear is the wiper in the middle. The clear is in the middle. That's your 0 to 10 signal. Okay. Red is flat 10, and then 14 is a common 0, and then so you'll have to flip the red and the clear. You have to flip those two. When you orient it, zero, that's 0 to 10. This needs to be so that it's pointing up with the tab pointing up. If you've got 0 here at 7 o'clock, and 5 o'clock is wide open, that's good. But this needs to be oriented, the whole thing, like pointing up with the white tab. Next would actually be doing the lights. Tying the lights into a relay. So your next part would be using an auxiliary relay. You got a class starting. You don't have one.
Good, Texas just online.
He's online now. So is he talking on Zoom or is it
Yeah,
just
it's just a sign.
a sign? A sign. So we would use a relay. An internal relay. You got a couple relays in there you can use. I would use this first one here. Common normally open. And then there's another one that they normally close. So you're gonna use two. So here's what we're gonna do. Let me just cut this here off. Okay. We're cutting the session off, whoever's out there, and hope you can watch the recording. And we will be back on here live again tomorrow. Have a good day. Hope you get cleared up soon.